I need like 20 more seconds and I'll get ready to start, so give me just a minute. Keep putting stuff in the chat, though. We got lots of questions to work through. Sorry about that. I was having a conversation with somebody, and I was trying to get out of it. You know those kinds of friends where it's like they just keep talking to you, and you're like, yeah, but I gotta go do something. I gotta go. And then they ask you another question, and you're like, I gotta go. And then they ask you a third question, and you're just like, well, I don't want to be rude, but I gotta go. So that was happening to me right now. And it was particularly relevant, so I kind of needed to not immediately cut that off. Welcome back to Chem 140. This is the review session. If you're looking at the chat right now, you can see that there... Oops, why is this not working? Oh, that's weird. There we go. For some reason, I can't mouse wheel up. You can see that. Oh, that's unusual. Okay. So, over here in the chat, I'm going to have the chat scrolled up to the top as I go through the questions. Like, I'm going to start here and go through them one at a time. As I do questions, they will accumulate down here at the bottom. Please just keep asking questions. You don't have to wait until I'm done. You don't have to wait for anything. If you have particular comments about a given question, do ask them, because I'll scroll down. Actually, hold on. Let me see. Can I fit everything on the screen? I can currently. I'm going to put it like right here. And I'll try and keep up with stuff. But if you have extra questions, like you're looking through your text or your quizzes or your notes or whatever, and you want me to do something specific, I can definitely do that. Oh, I didn't go get more water. Darn it. I have no water. I will deal with that later. All right, so Workbook Question 6. I had to get the workbook. That's right here. In Unit 7. So let me find that. And then what I want to do is I want to put it on the screen somehow, because I have the answer key for the workbook, but I don't have like a PDF of the workbook, I don't think. I have workbook answer keys, and that's it. But that's okay. I can make that work. I can make that work. Book. And so what I'll do is I'll just... Oh, it's already even at the top of that. Look at that. Okay, so we'll just... Where's number 6 here? There we go. I could just put it on the screen there. And then I can just do this, and will it stay? Yeah, perfect. Okay, great. So there's the question that we're going to do for the first one. So the average atomic mass of carbon is 12.011. Wow, this is a really tall document. Scroll, scroll, scroll. There we go. Considering only the two most abundant isotopes of carbon-12 and carbon-13, calculate the percent natural abundances if their atomic masses are these numbers. So first things first, we're going to write down the formula for atomic mass. So the average mass, or the atomic mass, is going to be equal to the percentage of the first isotope, which we'll call 12, plus the percentage of the second isotope, which we'll call 13. Okay, and the numbers that we know, so we know the average mass of carbon. It says right there, 12.011. And we know the mass of 12 and 13, but we don't know the percentages. So I'm going to replace those with variables that we're going to solve with. Oops, that's the eraser. Hold on. And I know that if I have two things that are percentages, they have to add up to 100%, right? So now we're going to have to solve for x and y in this system of equations. So that's not difficult to do if I substitute. So I'm going to call this equation 2 and this equation 1. I'm going to take equation 2, just like we did the other day. I'm going to solve for x. Or I'm solve for y. And then wherever y appears, I'm going to just substitute this in there. And because it's a review session, let's just do all the algebra, right? So you can see it in action. So M average is x times the mass of carbon-12 plus 1 minus x times the mass of carbon-13. And I'm going to factor that in, or I guess FOIL that in, right? This is equation 1, by the way. So I didn't do anything here, but 1 times M13 is M13. And then minus x times M13 is x times M13. And then I'm going to move all the terms that don't have x's in them over to the left. So this is going to go over there. So M average minus M13, because I subtracted it on both sides, is x times M12 plus, oops, not plus, I'm sorry. I have this minus here, so minus x times M13. I wrote that plus and I immediately was like, wait a second, that's not right. Because I've done 70 billion of these. And so now I can factor out the x, right? Because I have an x in both of these. So that's the same as me writing this. And this stays the same. And now I just divide by that parenthetical expression to get my x. There you go. Now we assigned x up above as the percentage of carbon-12. So x equals the percentage of the isotope 12, and y is 13. So let's now fill in the numbers based on the problem. So the average mass of carbon was 12.011 AMU. Carbon-13 weighs 13.0033 AMU. Carbon-12 is exactly 12. I'm going to underline it just because we know it's exact. And then 13 is again 13.0033. So I need to do these subtractions. So I have a thousandths place and a 10,000ths place. So I'm going to end up rounding to the thousandths place. And then down here I have infinite places and the 10,000ths place. So the bottom number is going to go to the 10,000ths place. So I could set these up horizontally, but you can also just count places. And just so I'm not using as much screen real estate, I'm doing it that way. So 12.011 minus 13.0033. And I get negative 0.992 going to the thousandths place. So I should have 3 decimal places because of sig figs for subtraction. And again, don't worry about negatives because they'll cancel if you're doing this right. And then for the bottom calculation, 12 minus 13.0033, I get 1.0033. And my AMU cancels out. And this is all x. So the top number divided by the bottom number. And I get 0.989, which is the same as 98.9%. And then if x is 98.9%, y is just 1 minus x, which would be 100 minus that percent, which should just be 1.1. And so this is carbon 12, and that's carbon 13. And there's the solution. Now you'll notice that my sig figs are different from Samita's because what Samita may have done, so if I scroll this back up here, so this is the answer key. What she got for number 6, she had more decimal places. So there's her answers. And the reason she has more decimal places is she made a mistake right here. So she had 3 sig figs, and then suddenly her answer had 4. So I'm going to say that my answer is correct. But that was let me scroll back down to the problem so it's actually on the screen here. There we go. Okay. All right. So that's the solution. And let me know if you have any questions about that. Let me just check to see that there aren't. All right. So that was that first one. So we could scroll that one off the screen. So unit conversion questions in the workbook. So unit 3, I don't actually need my workbook up, and I'm not gonna fool around with that because that's just gonna waste your time. So we'll close this and we'll put it. The cat can sit on it, I guess. So let me get the workbook for unit 3. All right, and you wanted 31 and 34. I scrolled right past it, didn't I? Yeah, there's 31. Okay. I'm going to try and scroll Samita's answer off the screen. All right. I think I have a question like this on the quiz. So this is a good question to review. I don't know how much space I have down here to work. I have enough space, so we'll just keep going. Where'd my pen go? There it is. All right, so the sun... Here's Earth. Is about 93 million miles from the Earth. Fun fact, long time ago, there was a TV show called Who Wants to Be a Millionaire? This was the $1 million question. This is the hardest question that they asked for a set of questions, and I knew the answer. My parents were like, there's no way you know the answer. I immediately just shouted out, 93 million miles! Before the answers even came up, and they were shocked that I knew that, because I was like 14 or something. And the reason that I knew that was because I had a little book on like astronomical concepts and numbers, and I had memorized them all because I thought it was interesting. So random trivia like this can actually win you $1 million. But yeah, this is the $1 million question. How many miles from the Earth? How many miles is the sun from the Earth? And of course, what they did was they played with factors of 10. So one of the answers was 9.3 million miles. Just so if you 50-50, you would get both of those, right? All right. How many seconds will it take for light to travel if light travels? You guys don't know what c means. C is the speed of light. I'm just going to leave it there. 3 times 10 to the 8 meters per second. And I want to know how many seconds it would take. Now, to convert a distance into a time, you need something like this, right? Now, these units don't match, so what I need to do first is I need to turn this into meters. And then I can turn meters into seconds, and that will solve the question, right? So let's do that. So 93 million miles. We're going to turn it into meters. Well, the only version that I know is to do this. I mean, you could do it any number of ways, but this is the way that I do it in my head. Because I would turn miles into kilometers and then kilometers into meters. So I know that in a mile there's 1.609 kilometers, and in a kilometer there's 1,000 meters. So this would tell me the number of meters. So if I hit equal, I would get a number of meters. But now what I'm going to do is I'm going to do this. Because now I would cancel this out, and it would tell me how many seconds it was, wouldn't it? If I did this. Because in 1 second, light goes 3 times 10 to the 8 meters, right? So I can just turn meters into seconds directly. And now I can just times it all together. So that's what I'm going to do. 93 times 10 to the 6. That's not proper scientific notation, but nobody's going to care. It's not like this is online for the world to see or anything, right? I should probably write 9.3 times 10 to the 7, but it all goes in your calculator the same anyway. And when I do this, the number I get is 498.79. Which we then need to report to however many sig figs we should have, which it looks like is 2. Because this is 4 right here. So for 2 sig figs, I would report 5.0 times 10 to the 2 seconds. Because you can't just say 500 here, because 500 is only 1 sig fig. That would not be enough precision. So yeah, almost 500 seconds for a photon of light to go from the surface of the sun to here. Now, the reason we only get 2 sig figs is there's a bunch of reasons, right? So for one, we don't have the distance between the Earth well defined. It's 2 sig figs, right? It says 93 million miles, but it could actually be 92,600,000, right? So that's 400,000 miles difference in either direction, either too little or too much. And that's going to cause light to spend a little bit less or more time than 500 seconds, depending on what it actually is. So we only really know to within 10 seconds here. All right, so there's that one. And then 34, you said. So let's find 34. That's unit 3. Wow, you guys don't like astronomy, do you? Jupiter is 4 times 10 to the 8 miles from Earth. Radio signals travel at the speed of light. How many hours would it take for a radio signal from Earth to reach a spacecraft passing Jupiter? I'm going to make all my questions outer space from now on. Just not because I want like you guys to struggle. It's because they're cool questions, but it will inspire competence, we're going to say. That's what I'm going to go with. All right, so we'll do this. So here's Earth, and here's Jupiter way over here. So I want to go this many miles, and I'm going to send a radio signal. Radio is just a wavelength of light. We're going to talk about that 161. All light travels at the same speed regardless of its frequency. And I want to figure out how many hours it will take to get to Jupiter. Now, believe it or not, this is the exact same problem with one step that we're going to change at the end. So let's do it the exact same way. So I have this distance, which I'm going to then turn again into meters because I got to make these match, right? So we'll turn miles into kilometers. 1 and 10 to the 3. And then I can again turn meters into seconds by doing this, right? So, and that would tell me how many seconds it takes to get there. But I don't want seconds this time, do I? I want hours instead. So if I do this, how many seconds are in an hour? It's just 60 times 60, right? I should have turned it into minutes and then minutes into hours, but this is good enough, yeah. All right. And so my answer should only have 2 sig figs because of this number. So I'm just going to punch this in the calculator. Not minus, I want times. Times 1,000 divided by 3 times 10 to the 8 times 60 times 60. I got 0.59592592592. To 2 sig figs, that would be 0.60. Or in other words, about 36 minutes. So if you send a signal to Jupiter, it will get there 36 minutes later. So if in like the year 2100, when we have like colonies on various moons and stuff throughout the solar system, if you send a message to your loved one on Jupiter's moon, it'll get there in half an hour. Which kind of frustrating, right? And also that's going to depend on the time of year and how close we are to Jupiter. So half a year from now we'll be on the other side of the sun, but Jupiter won't have moved as much. So it'll take like twice as long. Right? Imagine the lag trying to play games that way. You know, just things to think about for the future. All right. 10 on Unit 4. Let me get the Unit 4 worksheet going. 10, that was what I wanted. All right. Calculate the volume in gallons of 0.565 kilograms of liquid if its density is 1.5 grams per milliliter. All right, so I have this much liquid. Is it 565? Yeah, kg. And I want to get a volume, and I have a density. Now, if I have this and my density is in grams per milliliter, remember, you got to make a match, right? So you use the speed to change from meters to seconds. Yes, that's correct. So speed relates distance and time. That's what a speed is, right? You can go this much distance in this much time. So you can convert back and forth. If I know how long I get, I can figure out how far I can go at a given speed. And if I know how far I want to go with a given speed, I can figure out how long it will take. So time and distance are related through speed, just like how mass and volume are related through density. Because this is the formula for density, right? It's mass over volume. It relates the two. Speed or velocity relates distance over time. Same sort of relationship, so we can use it as conversion. That didn't delete. There we go. So I'm going to make these units match, because in order for our units to cancel out, we have to make them match anyway, right? And now I can turn this mass into a volume. So if I do that, I now have an answer in milliliters. So if I hit enter here, I would get an answer in milliliters. But the problem doesn't want milliliters, it wants gallons. So let's just turn milliliters into gallons, right? And then that'll be the answer. So this is the most efficient way I know to do that. I know how many milliliters are in a liter, right? 10 to the minus 3. And I know how many liters are in a gallon because I can go look that up on Google. That one I don't have memorized, though. That's not at all what I want. 1 gallon to liters. 3.785. There we go. And so this would give me the answer in gallons. Now, fun fact, if you see numbers like this, 10 to the 3 and 10 to the negative 3, and you're multiplying them together, 10 to the 3 and 10 to the negative 3 multiplied together gives you 1, because it gives you 10 to the 0. So you just cancel those out. You don't even have to put them in the calculator. So the only number I need to worry about is 0.565 divided by 1.500 times 3.785. And I got 0.0995. Which should have 3 sig figs based on... Oops, my arrow didn't show up. That. And let's see how he did. Oops, I can't see what's currently in the box. There we go. Dun-da-da. I swear I'm not looking at Samita's work, because she likes to write out all the numbers and then do this little squiggly line thing here. And I just can't be... Oops, there we go. This thing right here. I can't be bothered to write out all the numbers. Because most of those numbers don't matter to you. Also, she got extra numbers. I want a calculator that does that. All right. Where are we? Error as far as how sig figs and that go together. So Chris, I don't know if I understand your question here. So you'll have to come back to me. Brand, Unit 7, question 1. Do I still have Unit 7 open? I do. Okay. So we'll scroll all the way to 1. So this question is really just a checklist. And so I'm going to leave the checklist on the screen here, and then I'm going to write the questions down. Oops, I can't do that, though. That won't work. That makes it go away. Oh, and I can't move this either. Oh, no. Okay. Well, I'm just going to have to go back and forth. So I'm going to pick a random question. I'm going to just pick... I'm going to pick sugar, because that sounds good. So I'm going to pick this. I'm going to pick this. I'm going to pick... I'm going to pick ammonium. And then I like this one too. So I'm going to just pick these. And we'll just go through the checklist. Okay. So, is it an atom? No, because there's multiple atoms here, right? Is it diatomic? No. Is it polyatomic? Yes. Because there are multiple atoms, right? Is it heteroatomic? Yes. Because there are multiple different atoms in there. I should write molecule there too. Ah! There we go. Is it homoatomic? Well, it can't be homoatomic and heteroatomic, right? Is it a cation? No, there's no positive charge. Is it an anion? No, there's no negative charge. Is it a monatomic ion? No, it's because there's more than one atom. Is it a polyatomic ion? No, it's not charged. Is it an element? No. Is it a compound? Yes. So those would be what I would write down for this one. And really, the way that you would do these questions is you just have to go through the list. It's a checklist, right? Don't try and hunt and search for the ones that are familiar. Do them just straight down the list. Because I guarantee if I was just like, okay, this is probably, it's got lots of atoms, so I'm going to look for anything with lots of atoms. Because you're going to get confused, right? You're going to skip over some criterion. Let's do the same thing for N2. So N2, is it atomic? No. Is it a diatomic molecule? Yes. Is it polyatomic? No. Is it heteroatomic? No. Is it homoatomic? Yes. There's only one type of atom. Is it a cation, anion, monoatomic ion, polyatomic ion? No, it's not an ion. There's no charges, right? Is it an element? Yes. Because there's only one type of element there. Is it a compound? No, there are not more than one type of element. All right. And then we'll just do these other two. So, is it an atom? No. Diatomic? No. Polyatomic molecule? No, it's not a molecule, it's an ion. So, is it heteroatomic, though? Yeah. I would call it heteroatomic. I would call it an ion rather than a molecule, though. Is it a cation? Yes, because it is positively charged. And then it is a polyatomic ion. And then this one, I would not call an atom either. I would call it a monoatomic ion and an anion. I don't think element is appropriate here because it's an ion. So that's where I would go personally with that. All right. Where are we now? Let's see here. Quick review of precision versus accuracy. So the fastest way I can say for that is if I draw a giant bullseye. So here's my center. You know, doing that in a solid color, probably not the best. Oh, it will work if I do blue. So all right. So here's my target. And what we'll do is we'll just draw on a new layer here. So if I were to hit the target like this, precision is how close your data is together, right? So I would say, okay, is this precise? Yeah, my shots are very close together. Accuracy is how close you are to the target number itself. So here I would say, well, I was off by a lot, so I would say this was not accurate. Now, there is some leeway in judgment that you have to do. Generally speaking, if you're only off in the last digit, I'd call that precise. Or, I'm sorry, accurate. If you're further off than the last digit by a lot, if it's like, if you have like if you're off by 9 in the last digit or 10 in the last digit, which means you move over to the second to last digit, I would still call that precise. There's not really a fixed percentage that I reliably can refer to, I would say. Visually, it's very easy to see. But when I give you numbers, you do sort of have to go with your judgment. And you should be able to tell which numbers are precise and which ones are accurate and which ones are both or neither. So if I then did, say, we'll just do that. If I said, okay, here are my shots now. And I would say, are these precise? Well, they're sort of everywhere, so no, right? But if I take the average, and the average being, okay, well, Let's intersect these guys together. Here's the average result. That's remarkably close to the target. So the average would be good. So this would be accurate but not precise. And this is mostly dumb luck that something is accurate. Like if the target number is 10 for like a mass of something, you're doing an experiment, and you get a 7 and a 13, your average is 10, and so you performed accurately. But your results are not precise because they're off by a lot, right? So that would be precision and accuracy. When differentiating between monatomic and polyatomic, am I looking at the subscript number or how many elements there are? So monatomic and polyatomic refer to the number of atoms, so you do have to consider the subscripts. So monatomic means one atom. Polyatomic means many atoms. So you would count them. All right, where am I now? Okay, so it's just this lab question. So lab question 13, the mass of the vial and the volume of the liquid are the same as the original situation. Yes. So that one is the one where it's either Ava or Contessa. I forget who. Make sure you get the names right, because what a lot of students do is they go back to the previous, or they go back to problem set A or part A or whatever, and they grab the wrong person's data, and so they have the wrong volume. So be careful about that. But the intent is that the experiment for for Contessa is the exact same. So she uses the same vial she used before, and she uses the same pipette. So she has the same mass and volume of liquid, but the material, not the same mass. She'll have the same volume and the same mass of the vial. The mass of the substance, I believe you have to calculate based on the tools that are used. And then for the graph, do you want y and r squared on the top? I want them on your graph somewhere. Google Sheets will just automatically put them at the top next to your title, and that's perfectly fine. I do want the y and equals, and I do want the r squared. If it doesn't say y equals and it just presents an equation, that's totally fine too. So like if it just says 0.8x plus 0.999 or whatever, and it doesn't say y equals that, that's fine. There should be an equation though, and there should also be an r squared value. We don't use r squared in this class because we don't do statistics. We don't do enough trials for statistics to be meaningful. But looking at r squared is a good first approximation of how good is your data. And if you see like 1 or 0.999, then your data is good. All right. We made it through the first hour. So what I'm going to do is I'm going to put the break timer card up again. So we'll do this. If you have more questions during the 10-minute break, please feel free to answer or ask them. I'm just going to let the timer keep running until I feel like we have sufficient answers. Or not sufficient answers, but sufficient questions. And then I will come back and answer them. So we'll do this, and I seem to have lost my music. Where did it go? Where did it go? That's bizarre. Did I move it over here? This is the problem when you have 17 windows open. So I will fix it, and the music will be up shortly. So I'll see you in just a bit. Hi, everybody. I'm going to turn the music down really quick and just let it keep doing whatever it's doing here. So I don't have any more questions that have popped up in the chat. So what I'm going to do is I'm going to call last call for questions. We'll type that in the chat here just so. So last call for questions. So if you have anything, I'm going to let this run for about 3 more minutes or so. And if there aren't any questions, then we'll just do our little outro. Oop, I'm dropping frames. Sorry. Let me repeat that because I just saw that it did that. I'm going to let this run for about 3 more minutes. If there aren't any more questions at that time, then we'll do our little outro and so on. But otherwise, please do type in anything that you think is a question that you'd like to ask or whatever. So, last call for questions. Hey, I see a question. Perfect. Yeah, let's do that. Let me get rid of this music. You can't hear it still playing because I have to turn it off separately. Alright, so let me, oh, I gotta merge the layers. Hold on, because, not delete layers, merge layers. There we go, so we can clear all this. Alright. So we got a dog, and the dog eats... Well, you know, I can get rid of this. Oh, it's not even on, actually. Let's get rid of that. There we go. So dog eats 282.7 grams of food each day. So if I write that down, 282.7 grams per... I almost wrote grams per dog. How many years will it take for the dog to consume a total of 130.6 pounds of food? Okay. So I can turn... So if I take this relationship, this is a mass over time relationship, right? So I could turn a mass, which would be grams, into a time, which would be years. I just had to deal with the units in the meantime, right? So first let's make the units match so I can use the conversion. And I have that memorized, so I don't have to go look it up. So now I know how many grams are in 136 pounds. Now I can turn it into time by going from grams to days, yeah? So this puppy, or dog, or... I guess it's a dog. 282 grams is a lot. That's how many days it would take him to eat this much food. And then, if I want to turn that into years, there is 365... oops, hold on. 365.25 days in a year. We don't need this extra S here. And so this would give me an answer in years. So how long would it take the dog to eat this much food? So it'd be oops, hold on, I wrote the wrong number. 130.6. 453.6 divided by 282.7 times 365.25. And so I got 0.5737 years. So half a year. I hope you have a Costco card for this dog. You're going to be buying a lot of puppy food, or a lot of kibble. Or a Petco membership, or whatever. It's like buying kitty litter for my cats, really. Like, I buy the 40-pound bag probably once a month or so. Because cats go through a lot of cat litter. I gotta change the cat litter today, so this problem has reminded me to do that. Thank you. Alright. That was the only question I had in the break. So we're gonna call it here if there aren't any more questions in like the next 10 seconds. So we'll go back to the title card. I want to thank everybody for coming out to the review session. I hope that was at all helpful. Remember that I don't have to answer questions live. I can answer them for you in the Discord channel or over email. Either of those works. But yeah, keep in touch with me. Ask questions as they come up. I'm available. I might not be available 24/7, but if I'm at the computer and I see your question and I have time to answer it, I'm happy to do that. So keep that in mind. The only caveat is I can't do anything on the day of the exam. So I can't answer any questions on Friday or Saturday. Nobody's asked for Thursday yet, so Thursday's fine. All right, that's all I got. Make sure you get lab worksheet number 2 in tonight. It's due. Do quiz number 4 for some extra practice. And good luck on exam 1. We're all counting on you.